Okay, it is 11:02, so we're going to kick this off. I wanted to thank you all for attending today's Expert Insights webinar. My name is Chris Pichuta, and I am the Senior Business Development Analyst here at PSD. We are recording this presentation, and we will share it with all attendees once it's available. Today's webinar is Integration Aggravation, how to keep your sanity while connecting software. If you have any questions during the presentation, please post them in the question box and we will answer them at the end. And without further ado, I would like to introduce our presenters for today, Zach Critchlow and Chris Kubels.
Hey, good morning. So I'm Zach Critchlow, product manager, 7 years here at PSD, many of those years as software delivery manager. I've supported various program types, including residential audits and energy efficient product rebate programs. This involves many software integrations. Been responsible for projects including data syncing between systems, data extracts and data transfers to utilities and other parties, TRM calculations services, an integration with optical character recognition for instant rebate processing and whatnot. I'm also involved in the Heat Pump Plus retrofit toolkit for energy modeling, which is integrated with Energy Plus. So I'm excited to talk about the challenges and lessons learned on today's topic.
Thanks, Zach. Good morning. I'm Chris Kubels. I'm a solution architect at PSD. I've been here for almost 5 years now. Started as a software developer, and my very first project at PSD was integrating with a utility API for account verification. After that, I quickly moved on to integrating with Green Button. This involved processing hundreds of millions of meter interval data to help target municipal buildings as good candidates for energy improvements. Soon I started to transition into more of a business analyst role, meeting with clients, gathering requirements, and designing implementations with the team, until finally falling into solution architect role, where I think about long-term architecture, roadmap, and design of our software ecosystem and products. I'm very excited to talk to you about today's topic.
So PSD is a technology facilitated energy program implementation company. We combine building science with technology to help utility companies, program implementers, and building performance professionals achieve decarbonization and energy efficiency goals. PSD is the company behind Compass, the software platform used throughout the country for the administration of demand-side management energy efficiency programs, including work with NYSERDA. For over 25 years, we've built relationships and partnerships across the industry. A crucial component of our work has been establishing proper software connections, and that is what we're going to talk about today. So software integrations are a crucial part of software development, and doing them well is a challenge. They are not to be estimated or taken for granted. Poorly designed or poorly executed integration can lead to added stress and confusion for everyone who has a stake in the success of the program. It can also create unplanned work and destroy productivity and trust. So today we'll talk about goals of integrations, some steps for success, integration systems, structure and types, security considerations, some examples of integrations we've worked on, and some lessons we've learned. And if we have time, we'll go into some questions. So what are the goals, some goals of integrations? Connecting two or more systems. When you're operating in two systems or more for different purposes, you want to ensure that all users are working from data that is current, which may involve syncing. For example, you may be entering and approving projects in one system as program staff, but tracking pipeline and savings incentive information in another as a program manager. A workflow automation is another goal. It tends to involve data checking and processing. Common integrations for workflow automation are utility account verification for checking that a rebate applicant or an energy audit customer is in the utility master file. Another use case would be maintaining a qualified product list, where you would integrate with something like Energy Star's API. Data entry, where we want to maybe automate the connection between a system that a contractor that might be using to enter details of an audit or a home performance job, and that needs to go into another system for workflow processing, for approvals and payment processing. Third goal would be reporting and data aggregation. There's often one system that ultimately the client needs that will compile all the program data and organize it to be used to report to other parties like EM&V, evaluators, public agencies, and whatnot. So there are several factors to consider if you want a successful software integration. Communication is key. It's the most important thing. Requirements must be known and understood by all parties involved, so they must be discussed and documented early on. If there's existing documentation, make sure that it's up to date. Requirements must be analyzed for feasibility, as some requirements may be more complex to implement than they seem. Risks must be identified, and you'll need a sound strategy, architectural design, and management plan for your integration. So during implementation, it's important to document and test. A test plan is a must in that case, and a test environment dedicated for the integration is recommended. Once live, maintenance, support, and monitoring are also really important. Ideally, there will be little maintenance needed if everything is done well, but you must have a plan regardless in place just in case incidents arise.
And some different types of integration systems, structures, and we just kind of want to go over sort of some of the high-level things that we implement here at PSD. Some integration systems that you might be familiar with are enterprise application integration. This is sort of when you have a suite of software systems and you need to maintain integrity between them, like a payroll management system, your customer relationship system, and you may need all your employee data in one system synced with another. Data integration is where we bring all system data into a unified view, something like Power BI or Salesforce. Electronic document integration. Some examples of this might be SharePoint or OneNote or Office 365, sharing documents between all of those systems. Some of the structures of integration that we do here at PSD are point-to-point is probably the most simple and straightforward integration structure. And that's sort of where software applications communicate directly to one another over either an API or maybe a file transfer. It's a pretty straightforward structure for integration. Star integration is, or otherwise, I think it's also called like hub and spoke integration. And it sort of looks like that. If you were to draw it out, there's a central hub that connects data between multiple systems. This is something that we do a lot of at PSD. And then there's horizontal integration structure. And horizontal integrations are software applications that are sort of unaware of one another. They're not tightly coupled. You could think of microservices as sort of a horizontal structure. They typically require some sort of messaging system to communicate to one another. But generally they're kind of unaware of one another. And then there's integration types. And these are sort of the different protocols or ways you can integrate. API is probably the most common integration type. I find API is probably the easiest to work with. Secure file transfer or uploads. We do a ton of this at PSD. Sometimes this is a good way to do integration. Other times it's a little challenging. Orchestration and middleware. We do a lot of this. This is sort of that horizontal structure where you have a lot of independent applications that kind of work to orchestrate between a bunch of systems. And then another common type of integration would be webhooks. These are pretty familiar in sort of the large software systems, like even like Facebook and things like that have webhooks that you can configure where when certain actions happen in the software, a webhook will get triggered to go do something. We don't do so much of that at PSD, but it is a common type of integration.
So security is something we want to consider, have it at the top of your mind when dealing with any type of integration between systems. Integrations with utilities often involve customer data, so you must take careful consideration for how you approach those system interactions that involve the personally identifiable information, or PII. You'll likely store PII in your internal systems, which means you must protect it and have retention policies and incident policies in place. There are massive consequences for losing or exposing any of this kind of data, including financial and legal penalties and damage to your reputation. So access control to PII is critical, and because it may have a way of escaping secure boundaries without the proper policies and procedures in place.
Some other security considerations, kind of on a more technical side, is there's many ways to protect the actual transfer of data to prevent man-in-the-middle attacks or other hacking attacks. And one of those ways is to make sure that you're doing a secure file transfer, SFTP. When you use an SFTP system, all of the data that's transferred is encrypted. So anybody that's sort of in the middle of that can't really get to that raw data. But secure file transfers don't necessarily imply security unless you combine that with good access control to your SFTP server and data retention policies. There's some examples where you could have an SFTP server running, and where those files are actually persisted may be available to users that you wouldn't want them available to. So you have to be really careful of where the data ultimately gets stored, and how long you store it for is an important consideration. Encryption is another good method of protecting data after the transfer from one system to another. Usually this requires public or private key pairs. These usually have expiration dates. So there's typically a bit of an ongoing maintenance cost with any type of encryption. And of course, there's TLS and SSL considerations. All of our software must follow best practice for TLS and versions and be secured behind SSL. All of our APIs are behind industry standard security protocols, including TLS 1.2. And again, there's always a maintenance cost to maintaining these certificates in security. A firewall is another good security consideration. This limits who has access to certain systems. This often requires to set up blacklisting or whitelisting of machines that can actually communicate with the software. This is probably one of the best ways to secure your software, is to put it behind a firewall and only allow specific access to it. But there's a lot of challenges to that to integrate with software that's behind a firewall. We'll show some examples of that later. And then, of course, authorization. And typically, a lot of the integrations we do deal with PII data or sensitive data. So credentials, API keys, tokens are all effective ways to protect an API. Some even more secure ways to protect an API would be to authenticate using an SSH key. We find that to be kind of challenging to integrate with because those SSH keys typically need to be protected, meaning that you can't like give them to a developer to test the API from their local machine. So sometimes there's challenges that you need to work around with these security considerations in mind.
So security considerations aside, there are many common pitfalls that you want to be aware of. So although automation is a great goal to reduce administrative costs, sometimes the cost of implementing automation will outweigh the benefit. This would be true for program designs that become overly complex. So you will come across programs that are very complex in design, but the participation volumes may not justify building out a very convoluted automation, unless the system the rules in the system kind of start off very simple and you build off of that. Lack of documentation or requirements is another pitfall. All parties must know what they've agreed to so that coordination is smooth. And you'll understand where things go wrong if one party makes changes and doesn't communicate or doesn't follow the procedures that are agreed upon. Documentation needs to be up to date, as I said before. It could easily go stale if not kept up with. A lack of a sandbox environment is a typical pain point where it could constrain proper testing and getting the necessary feedback. When you're testing an integration with a production environment, you do have the potential to interfere with production data or progress or the running of a program. Scope creep, which is something that plagues really any software project, but the scope of a project can expand, causing the budget and timeline to blow up. This is sort of related to number one, where you want to make sure that your designs are pretty simple and easy to understand, so that automating them can be pretty simple and straightforward. And then you could build upon on top of that. As long as you have a strong foundation, you then have the flexibility to start adding things to it. Sometimes you have to work with other systems that may not be maybe a little bit outdated, or maybe not greatly maintained, or maybe poorly designed, frankly. So that could be very challenging and can be hard to avoid in some cases. So you need to make sure you recognize those early on and try to factor that into your planning. And one thing that's not on here is Friday evening deploys. Just try to avoid deploying to production on Fridays. I think that's burned quite a few people who have weekend plans. So next we'll talk about a few examples of integrations, some projects we worked on. We'll share some thoughts on those projects. I'll introduce maybe the use case, and then Chris will go into more of the technical aspects of them. So the first one will be account verification. It's a data validation use case where you must confirm that an individual who wants to participate in the program is an active utility customer. That's the most common one. In order to do this, you must check that the applicant is in the account, is an account in the list that the utility maintains. The problem is like you need to be able to access this list, right? And accessing that list is typically managed in a couple of ways. One way is through file transfer, which Chris will talk about. And another would be APIs, which we'll also talk about.
To dive into some of the details of implementing with account program verification through file transfer, some of the objectives are we need to make sure that we are paying attention to security here. These files need to be transferred securely. They need to be encrypted. Typically, they include lots of sensitive data in them. It needs to be an automated process. We don't always know when these files will drop. Sometimes there's an agreed upon cadence, sometimes not. So we need to automate it. And because this is such a common thing that we do across all of our clients in different implementations, we need to design some convention around this process so that we can easily and quickly stand this up for additional clients. Some of the challenges we faced are the consistency of the files. I'm not sure what causes this generally. I'm sure there's lots of different reasons, but sometimes these files we would receive would have missing data in them, missing columns in them, and weren't consistent with what we agreed upon, or there would be changes to these files just suddenly appearing without anybody knowing they were changed. So dealing with that sort of issue. Security, of course, we need access control. When we're dealing with files, we typically have to ingest all of this data and then discard the file. And that means that we hold the risk of maintaining the PII data. So there's a high cost there for ensuring that data and having incident response plans in the case that data gets accessed by bad actors. Monitoring is really important. We have to make sure that this process is successful, that our data is good. And with files, you will always have stale data. I guess it depends on the cadence that you receive these files. Typically, they're monthly, so we're generally dealing with about a month of lag, which is a challenge sometimes. Some of our solutions to these challenges involve automated verification of the files. So because we realize the consistency of the files is sometimes not great, we must first validate the file before we even do anything with it, and make sure we have proper monitoring in place to alert when files are not good. We use PGP encryption. This involves public and private key pairs. This is a pretty industry standard encryption method that we use all over the place. And for convention, we built an ETL process, extract, transfer, and load, that applies a convention on it. So regardless of where the source of the data is or what exactly the shape of the data is, we can always feed it into this ETL process, and the output into our software is generally the same. So it's sort of a reusable convention that we design, which helps us stand these integrations up pretty easily. We have a small retention policy on, a short retention policy, meaning we don't keep these files around. We don't keep the raw data in them around. When they get transferred, they get processed, and then we get rid of them. These files are also, they're dropped on a SFTP server. So we also have the ability to perform just-in-time access control, which means if an individual user does need access to these files for some reason, they can elevate their permissions or request to elevate their permissions to gain access to these files. The other side of account and program verification is to do this through an API. Not all utilities have an API offering, but the ones that do, we have to integrate with them. There's a lot of pros and cons to API integration for account verification, the same as there is for files. Some of the objectives that we have is we have to retrieve this data typically through very secure API systems. And we want to apply the same convention as we do to files to this API for ingesting the data and transforming it into our data models. The challenges that we faced are these APIs are extremely secure. They're typically behind a firewall, which requires a whitelist access. That is very challenging for developers. Typically, we're only allowed one or maybe two whitelists access to these APIs, and that generally means that developers won't be able to access them through their own machines. Different utility companies offer different API protocols and architectures. So we have to understand how to do SOAP requests. We have to understand how to deal with JSON or XML data. Oftentimes, the data that we received is very human entered or keyed in. So there's sometimes the data we get is not great or missing. So we have to sort of figure out how to deal with bad or missing data. Because these are APIs, they're not always available. Sometimes they go down, which is a big showstopper for us. And SSH authentication to some of these APIs is another real challenge because we have to protect those keys that we use to authenticate, and it just makes it hard to develop against. Some of the solutions we've done to meet these challenges are we built our own mock API that basically mocked the utility company's API so that we can control the data in our sandbox environments. We built this into the same ETL process as when we deal with file integrations. We have a monitoring of the API availability. So if the API goes down for some reason, we're alerted and we can react quickly. We've also elected a cryptographic key custodian. I totally stole that term from our policy, but it's a person who is responsible for managing our keys when they expire, when they need to be renewed. It's an important part of this. And to handle bad data, we have a system in our software called data quality tests, and it allows us to sort of check the quality of the data for account and program verification. And it prevents your work order or your program from submitting poor data. Sort of stops you at that point, and you can investigate the data and get any missing data you might need.
So HTML is, or it's also called the Home Performance Extensible Markup Language, is an industry standard to collect and exchange information among contractors, program implementers, agencies, and evaluators. It's also in the middle of some energy modeling integrations. So we use that a lot here at PSD. A home performance contractor may be using a specific software tool for entering audits or jobs. And then a program admin might have access to an HPXML file export from that first system, and then they could upload it to another system to capture measures and savings data. So that second system, which could be PSD Compass, would be able to facilitate the the processing approvals and the payment processing, as well as the data transfer to utility for reporting of that. So Chris has listed some challenges to this approach and some solutions here.
Yeah, when we did this integration, it took us a long time to actually get a real test file from the third-party system. So we started to build this without having proper test data. But HPXML is a standard. There is a well-defined schema for it. So we went with that and moved on without really having a test file. And because third-party vendors can generate this HPXML freely, it's a little hard on our side to control the data that goes into the HPXML. And one of the things that we found is that sometimes the data that went into the HPXML was not really, it may have been handwritten by a contractor, and there was no real standard to the actual values in the file. And that became real challenging to map this HPXML file into our data model. And also different vendors and different clients have different interests in this HPXML file. So because of those variations, the variations across clients was a challenge to deal with. Some of the solutions to these challenges were we had to build a mapping UI. There was no way we could determine a data dictionary to do that mapping. We had to build configuration or feature flags to switch things on and off for certain clients. And a future solution is I think we could review third-party options to configure on their side for better consistency between both of our systems. But sometimes this is hard because of often these third-party systems are already designed and built, and there is no option to change anything on their end. And just a quick screen cap of the mapping UI that we had to build. The HPXML measures, these are sort of, sometimes these are freehand typed. They had typos in them. They could be anything. And we sort of had to take these HPXML measures and map them to improvements and measures in our software.
So moving on, we're going to talk a little bit about demand response program that we implemented. So demand response programs designed to encourage customers to reduce their electricity, during, I guess, peak hours. One way of doing this is to remotely control smart thermostats of customers who have enrolled in the program. And Chris will give us a bit about that.
Sure. This implementation was really challenging. We had to manage all of the program enrollment and verification. We had to calculate all the incentives and automate payments to these customers. We had to synchronize our system with a third-party system, and we wanted to be the system of record in the whole process. Some of the challenges we faced were basically on day one, there was parts of the process that weren't really followed. So that was something we had to react to very quickly. The program design was extremely complex. It was a high volume program. At the end of this program, there's 50,000 devices enrolled, and that means 50,000 payments need to happen, all automated. Our system became out of sync with the third-party vendor who connects directly with these devices. The program allowed for multiple devices to enroll, but payments are only per account, per utility account. And different OEMs had different privacy terms, which made things challenging. Some of the solutions to these problems were we can react really quickly. So we did some hotfix patches to protect against the process flow that wasn't followed. We had really good automated end-to-end testing, and we invested a lot in load testing so that we know we could handle 50,000 automated payments. We spent a lot of time planning the design of the system. There's many process flow diagrams and documents about API structures. So it's very well organized and documented, which helped. Because our systems became out of sync, and that happens sometimes out of our control. You know, there's network issues. There's things you can't necessarily control all the time. We had to build a reconciliation API, which is basically a reporting API, so that the third party could retrieve all of the data in our system and make sure their side was synchronized. We had to go through a security audit for one of the OEMs to make sure we were abiding by their privacy terms. And I sort of stated above, we had tons and tons of documentation for this process. And we now have a very good streamlined process for running demand response and behavioral programs.
Payment processing. So an important part of, I guess, large volume programs is to automate the payment processing. So this is where we would integrate with a payment vendor. Because energy efficiency programs are driven by incentives, and you might say that dollars are the primary fuel source for these, you must entice people to sort of make more efficient choices at home. So program implementation isn't complete without payment processing, especially if you're doing it at scale. So whether that's sending checks to utility customers or bundled checks to contractors or distributors, or even just e-gift cards for folks who buy energy efficient appliances. It's crucial that you make this process reliable and secure. And Chris will go into some of the technicals on that.
Yeah, some of the objectives we had were there's several payment processors that we need to integrate with, whether that's for processing checks or gift cards. So there's just different integrations we have to do. We have to bundle payments. Sometimes contractors do a bunch of work, and we maintain sort of one unit of work at a time. And so we have to make sure that contractors aren't mailed, 50 checks. We want to mail them one check with the sum of all the incentives across 50 work orders. We need to track payments through a bunch of different systems. I think altogether there's about 4 separate systems. We need to track it through our work order system. We need to track it through our reporting system, the payment system, and ultimately we need to aggregate some of this data back to the utility. We have to reconcile with the bank. Our customer wanted to know when checks were cashed, when checks were returned. And we wanted to support instant rebates, meaning the goal of that was can a utility customer apply online and receive a gift card rebate within 5 minutes of filling out an online form. Some of the challenges: every payment vendor is unique. They're all different. They all behave differently, so we must learn them. Again, load testing. This was challenging because of some of the payment vendors' sandbox environments wouldn't allow us to load test at the volume we needed to. Integrating with the bank was completely undocumented. We had built this integration about a decade ago and needed to migrate it, and nobody knew how it worked anymore, and the bank didn't have really documentation anymore. So that was a real challenge. Keeping all the systems in sync is tough. And how do we verify instant rebates? Some of the solutions for that are we just had to build multiple support for multiple payment vendors. We did load tests 50,000 payments, but it involved coordinating with the payment vendor to sort of allow us to do that. One of our developers backwards engineered the bank reconciliation process, and now we have it well documented. That was a real challenge, but we did it. We built a nightly reconciliation process that sort of maintains data in all these other systems if things become out of sync. And we're really good at standing up lightweight microservices that sort of orchestrate all of the data between the different systems.
Sorry. Throughout the program cycle, an implementer, for example, may need to send data to a utility or another party. So the data aggregator will compile all the program data and organize it to be used to report, to an evaluator or maybe a public service commission. So you may have a schedule for this, for when this data must be transferred over and reconciled. And there's tend to be deadlines, whether they're quarterly, semi-annual, or definitely annual reporting. And it's really important that these things are done right. And I think you'll probably touch on some similar themes here, Chris, but what do you have?
Yeah, similar to the payment processing, we're always interested in automation. We want to be able to aggregate this data without thinking about it. Some clients require close to real-time data synchronization, which is really tough to achieve. And item potency is important, which means that we should be able to send the same request twice or the same data twice without a negative result. And we should have the ability to update data in these aggregated systems. The challenge is every utility or every integration we do, they're all different. It's hard to be consistent when we're integrating with different software. The real-time data synchronization is just a challenging thing to do. Security, who has access to the data, how we're transferring the data is always important to consider. And we wanted to make sure that these systems that are aggregating the data aren't tightly coupled to one another so that they can be easily changed or adapted in the future. The way that we handle these challenges is our flagship product has a very well-defined and mature API. So we can basically get to any of the data we might need to aggregate with already defined APIs. I said in the previous slide, we're very good at deploying lightweight microservices that can orchestrate data between multiple systems. We use an enterprise service bus is how we dealt with real-time data synchronization. Our software can publish events and when data changes, and we can have lightweight microservices subscribing to those events that will then move the data along. Sometimes these data aggregations are files. We have to generate files and ship them off somewhere, so we make sure we encrypt them and transfer them securely. And almost always, there's a reconciliation process. This is something that I think is you should really consider when you're doing integrations where systems need to be in sync. It's almost always an afterthought, but I think it's been on just about every one of these slides. So just something to consider.
Yeah, that last one, it's really crucial that there's a process in place by the implementer or the recipients of the data, that there's some reconciliation process, and the less manual, the better. But at some point, there always has to be something there. So you'll avoid having to go back in time and try to make adjustments or corrections to things you've reported on already. So we've gone through quite a few examples, and just to sort of wrap things up, if you work with PSD, like through our energy programs division or energy service engineering services, we are capable of implementing cost-effective programs and Of course, a big part of that is how we connect to other software services. As Chris said, PSD Compass offers a robust API that allows other systems to create, retrieve, update buildings and projects. We have a robust cloud infrastructure that supports the development of these microservices, lightweight and nimble. And we have a team of experts who can build and maintain them. Of course, we are SOC 2 compliant so that our change controls and data management processes are held at a high standard, sort of touching back on that security considerations slides we were talking about earlier. And energy modeling is very important to us, such as what we use for building envelope improvements, increasingly with heat pump simulations for electrification, or even custom TRM calculations, which we can be made offered through the API. And yeah, appreciate you all joining us.
Thank you so much, Zach and Chris, for this presentation. If you have any questions after this webinar or would like to learn more information, please contact KJ Kizar, our VP of Business Development, or Brendan Thomas, our Director of Business Development. Their email addresses are on the screen. Now we will answer any questions that you may have. And feel free to post them in the questions box. Well, while we let the attendees enter any of those questions that they may have, we did have a couple. What is the most important thing I can do as a client to make my integration successful?
I can sort of give my my response, and then Chris, you can follow up with that. I think you need to make sure you're not underestimating it. It takes lots of planning. You'll want to walk through the business process in detail and understand where your data needs to go and what you need to do with this data. Are you creating payments? Are you creating invoices? Are you calculating savings? Are you where is it being entered? Is it being approved in the same system it's being entered in? Things like that. We need to find out through and through who's involved and what the life cycle of a given project will have. I would also say that just starting conversations with those third parties that you've identified as early as possible to get sort of on the same page, so you aren't causing some of the documentational requirements or process inconsistencies that we kind of talked about earlier.
Yeah, I would say one of the most important things from my perspective is being honest and clear about responsibilities of each party. We've had situations before where it was understood that both sides were building automation, and then in reality, only one side was automating and the other side was sort of faking it and manually doing the automation. And that process ended up failing real quickly because we were so misaligned with what the expectations were. So it's important to communicate and work together and set expectations, and also everything else Zach said.
Okay, and there is another question. With any integration, there is usually a cutover date where multiple parties may be involved. What are the best strategies for a successful integration cutover?
I can start with this one. We've certainly had to deal with this scenario many times, and it's a challenge. But there's a few tricks I think you can assess to help in this. You almost always require heavy testing in sandbox environments. You really want to have the system set in a UAT environment and test it thoroughly. Another thing is designing contingency plans. What happens if one party fails in their deploy? Can you roll back? Having a contingency and plan in place, even if it's not a high risk, is important. And having a documented, coordinated timeline of rollout between all parties. Details such as like production URLs, keys, credentials should be tested and discussed well ahead of schedule. And another trick that if you can do is sometimes you can deploy systems early and they're just not used or hooked up yet. This is always a great option. You can deploy things to your production system early and sort of do some smoke testing on it and just have it sit there and wait until the final rollout date. That's always a great idea. And just having a plan is super important.
I would say don't do cutovers on Friday evening, unless everybody plans to hang out on that Saturday.
Sounds like Zach has some PTSD.
Any other questions? Okay, looks like we don't have any other questions. So I just wanted to, again, thank Zach and Chris for this presentation, and thank you all for attending. I hope you have a great rest of your day and a wonderful weekend.
Thank you.
Thank you.